Hey and welcome. Today we are about a 4D game engine. So the idea of a 4D game engine is not exactly new, and to be honest this thing here is almost 4 years old. But still, now I got inspired by a comment below a YouTube video of Code Parade, and I thought, well, probably it's time to refurbish this project, show it off to you, give you the code and some explanation of what to do with this, since this is plain C++, tell you a bit of my ideas what can be done with it, and maybe someone will make a 4D game out of this, or something he comes up with, gets inspired by, or something else. Because here, look at this. Look at this, Mega Cure, however this is spelled. This is actually a 4D game, and this thing is supposed to be released for an eternity, but it never came out, so let's take a look at it.
What if there was more to this picture? What if you could just walk around the wall in the fourth dimension? So you turn your face along the fourth dimension, walk.
Yeah, but you still walk in 3 dimensions. Look at this. And what is this around there? Water. I have no idea. They still walk in a 3-dimensional world, so to me this looks all kind of boring, because we're going to go to the desert. There is always some kind of floor, and then there are some kind of objects. I mean, I have to say, let's go to the beginning. Here, look at this spherical or something. This is clearly a 4-dimensional object that, I mean, it's very common for 4-dimensional objects to somehow get bigger and then smaller if you go along. But still, you always have this plane you are walking around, so it looks like it's stacked 3D world. So let's take a little look at this. I have made a paint sheet. Oh, yeah, that's so beautiful. So let's say we have 2-dimension. With 2-dimension is always easy to understand. So there is our floor, and then we have that new axis. So let's go in there, and then we have here some world. I just make now a 2D world, so there are some blobs, and then here is maybe a little creature that is walking around this planet somehow, and then here is maybe a sun that is radiating a little bit, and it gets to and an eye. Oh, it looks stupid. So, and if we take these worlds here and we always modify them a little bit, so maybe we just make it somewhere up here, and then we can just add a slider here to change in between these different 2D worlds, and they always here, I mean, the surface is literally the edge of this circle you can walk on, and they always have this flat circle you can walk on, and you're just choosing between multiple worlds that sometimes, I just say sometimes, imagine there is something like a cube inside of that, like this. Then they would have a connection, because you either see this slide or the slide at the top, and that's pretty much what is happening.
So I thought I would show you what it would actually look like
With this game here. This is actually happening with Mega Cure. But the great part is you're always walking in these planes that are just stacked onto each other, onto the new dimension axis. But what if you actually go in an angle like this? Then you see the objects in a totally new shape. So I think that's an addition that makes the 4D experience very real. So to get this to the point, if we look at MegaCure, we in this case we have not a first-person view camera, we have a fixed camera, and we can walk around with VASD and probably jump with space. But you see it, if we have VA, is it called V? No, it's called W. Oh, sorry, my English got worse. It's called WASD, and you can walk around in this 2D plane. But if it would be a first-person game, and I like first-person game, you had your person, and this person would look on some kind of view field like this, and then you had basically two angles. So the first angle would be something like this. So if we had a coordinate system, the first angle would be rotation around here, so in the x y plane, and the second angle would be something like up or down, so just orthogonal to the third angle. Well, this graphic is not good, I should replace that, go away. So the first angle probably will look something like this, and the second will be orthogonal to that. There, the arrows are a bit broken. So you have basically two angles, and that is what you get out of MegaQ as well if you would make this a first-person view game, and that is nothing more than you already had. So you could just make some other cheeky things like non-Euclidean or everything else, and it would not be that much more interesting. But if we go into 4 dimensions, we still have this rotation, we still have that rotation, and we will get another rotation. So we have now 3 angles we can rotate around. So in this ray tracing engine here, I implemented this. I implemented this here. So you have the scroll wheel for the Z angle, and you have the X angle for your mouse going left, and the Y angle for your mouse going up, right or down, respective. So left right is X, up down is Y, and you got the scroll wheel for the Z angle to up down. So you have 3 angles. It's like a first-person view game: up, down, left, right, and scrolling. Just you got 1 dimension more. Yeah. So this gives you definitely more opportunities. So finally, we need a way to depict, because if we have a 2D game, we render on a 2D screen made out of pixels, like I show you here. So a basic ray tracer works by having a point, then having a forward vector, a vector that is orthogonal right, and a vector that is orthogonal up, and then you have all the vectors you need to cast a ray through every of that pixel and check if it hits an object, like this gigantic, ugly looking cat. My drawing skills are superior. So a ray goes through here, and if it hits something, it will make this pixel black, and if it hits nothing, it will leave the pixel white. So we will get here an hit image of our cat where we did hit it, and the others are white. So there we won't see anything. This is a bit boring, so we can add something like texture, color, and so on. But in the most basic thing is just did we hit or not, so binary. Now for 4D-Raytracer we have a little problem. So the first thing we can do is we can take the 4D object and try to project it down to a 2D screen, and I implemented this first. So we have basically 4 dimensions to 2 dimensions. But the problem is this thing is incredible hard to work with, because if you're sitting behind a screen always seeing this 2D cut or this 2D projection from the 4D object, you basically get lost in a second and you don't know where you go. So you have no clue about how the 4th dimensional object is looking like. You're just lost, you're just walking around stupid. So I thought maybe we just do 4 dimension to 3 dimension. So for a ray tracer this would be our classical screen grid, something like this, but it is extruded into a cube. So we don't have a camera plane anymore, we have a camera cube, which is basically multiple camera planes stuffed behind each other. So if we want to make this into a new view, then we can do this like that. So that is our forward vector, and up and down there is our new axis, and forth and back is our new camera plane. So a line here, line here. It's looking horrific, but I'm trying my best. I'm literally trying my best. So this line here is actually a full 2D plane squished down to a line, and this here is just a stack of lines into the fourth dimension, which represents our stack of planes. And what we now do is, if we have a line that is on the top here, we color it blue. Let me take this here, blue. So everything up here is blue. If we have a line at the bottom, like a sky, the sky is always blue. If we have a line at the bottom, we color it red. And if we have something in the middle, we color it green, like grass. So it's hell, it's grass, like earth, and it's sky. So it's pretty easy to understand that everything in between will be just a blend between these two colors. So somewhere here will be yellow, and then there will be cyan somewhere up here. So now it's looking like a rainbow. And effectively the color of the object tells us where we are hitting and how much we are hitting. So if we are hitting green and blue, we get cyan, and there's just one thing I have just one thing I have to add. So you at this projection you can't distinguish if you're hitting cyan or if you're hitting blue and green. So that's why the lightning, so how bright the color is or how dark it is determined on how much strips you're actually hitting in the fourth dimension. But I think I talked enough, so let's go to the actual program. So what you have to know about this program is it starts at the main function, then it calls some initialization, and here it sets up just a plane over the screen and loads a shader and initializes the mouse callbacks, and down here this is actually a crucial part. So this actually takes the three angles we get from the mouse input and tries to compute the vectors which define our camera cube. There's some bugginess in it, and you've probably tried to work it over again. Maybe I'll do a little explanation later. So we have the header files which define some structures, and we have a vector3 and a vector4 C++ file, and finally the shader. So the shader has some basic objects like a plane, a box, a sphere, a capped cylinder, and a subtraction of objects, and in the SDF, in the assigned distance function, you combine them. So these are basically the objects you can render in the world, and in this function it returns the combination of objects you like. At the moment you can just subtract one from another. Maybe I'll implement something there later. And then you have a lot of ray tracing stuff. So if you want to look how a ray tracer works, I recommend you to just go to YouTube and put in Raymarcher. And you have plenty of tutorials you can follow. So I'm not going to do that over and over again. So this word render, and this is converge hue saturation value to RGB. Hue saturation value is just another way to note down colors. Take a look on Wikipedia. And finally, the void main of the shader, which does the following. It takes the screen position, so every pixel here is the screen position, and uses the screen position to get the right and up vector of that point, and then it iterates 400 times. So into your screen, you must think that you can just go back in that screen. I can show it with the mouse to you, and creates the depth. So it creates a 3D camera cube. So let's start with something very simple, that is a box. So P is the ray vector. You always have to pass that P here, and this vec4 is the coordinate, so the size of the object. At the moment you can't translate them. I did not implement a void translate, so a flow translate, so you can just set the dimensions and they will always sit at the origin. But I have to say something. You see probably that the resolution of this ingenious thing is 400 pixels times 400 pixels, so we have a ratio of 1 to 1 and 400. You think, yeah, that's crappy, but we also have 400 pixel in depth, so our resolution is at the end 400 to the power of 3, and that is a lot. And that is even more than this whole 4K screen here has in resolution. So what I'm going to do now is taking down the resolution. Isn't that beautiful? So we take this thing here and go all the way down to something that is still 16 to 9. Ugh, horrific. So finally we're there, and now I put in the box. I hope I did not make an error, because this is a text file. These shaders are text files. They're written in GLSL. You can all read about it in the internet. It's really boring, and you don't have fun to go through this shader language. And if it has an error, you can kind of print that in the console. There is some error tracing, but I was just too lazy. So if you work with my code, you have to make sure that there is no error in. You will just not notice if there's any. Yeah, it worked. So now the screen is green. I go a bit backwards, and we see this magnificent square thing here. Why is it green? Well, we have no orientation along the 4D axis at the moment, which means that everything we look at is just plain green, since everything is as you noted, remember in the paint image, we are not aligned with our view to the 4D dimension. So let's do that to see that the color changed. So I'm looking now upwards in the 4th dimension, and you see it's getting red. And the reason for that is very, very simple, because since we are looking upward in the 4th dimension, we will just have some image data on the lower end of our image cube. And if I'm looking downward, it gets blue. So let's go to Paint and take a look at this. Large. So this is our image plane. And here we were just looking to the... What did I do? We were just looking to the plane to the front. But now we are looking upwards into 4D, so we are just seeing something down here. Since our plane is shifted like that, and only here we still get rays hitting. And if we're looking downward, our plane is shifting like that, and we get something hitting up here of an object that is sitting right there. This looks like a 3-year-old painting, and it's a very low resolution. Maybe I draw it again. So our object sits here. If we look like this, and that's our screen, we just get some hits here, and that means red. If we look like this, and that's our screen, we just get hits here. And if we are looking straight onto it, and that's our screen, we get hits in the middle. And that's why we have, so the scaling here is not accurate, and that's why we get it green, red or blue. I should close this. So get back in. And you see, if I go further away, it gets dimmer and dimmer and dimmer and dimmer and dimmer, and the reason for that is that fewer and fewer and fewer of our planes get hit, and so there is a dimmer color, so we know how much is hitting. That's quite useful in some situations. There's something wrong with the mouse control. There's just something buggy on this resolution. It works quite well on the higher resolution, but on this resolution it just doesn't work. Look, now it's blue. So now we are moving somewhere in the fourth dimension. You see the halo of this thing? So you can actually look through the thing. So most people just look at different images from these 4D objects, but what they don't know, the important thing is actually happening inside the object, and you always look at the outside. So I'm going to demonstrate this to you. 4D cube. Here, it's again mega cure. Seems I'm just going to destroy them today. I have made wonderful things, but you look at these objects. What you see is always the same thing. You always see their surface. You do not see a cube if you look at a cube here. You see the surface, which is orange, which is blue, and which is green. So you're just looking at the surface of it. But what you actually should do to see what is happening in the fourth dimension is looking inside the object. And that's why here the corner is brighter, because there are more hits, if I look at this direction, in the corner from the 4D than on the edges. So there is actually more density in this cube. And if I'm flipping to a different dimension here, we see that the edges are blue, so there is less density, and we are hitting at the bottom of the screen with the edges, and in the center it's green and cyan. We're hitting at the top, at the top. So you actually can somehow see into this projection. So in the end, it's not really a projection, but it's another way to get the third dimension with color into our brain. And I demonstrate now how this is useful. So what are we going to do? We're taking our mighty cells and we make a cylinder. Something like that. Imagine you're a person that lives in plain 2D and you're sitting inside this hollow cylinder. So if you're living in plain 2D, what you're actually seeing from top view is, if you're inside here, you always see walls. So it doesn't matter where you turn to. Let me color the field of view. You always see wall. And we can do the same thing. We just make one of these capped cylinders and put it into a 4D capped cylinder, so that is all a cube, a sphere. I'm going to show it to you. That makes it easier. So we're taking our mighty thing here and remove the box. Don't need the box anymore. So you see, where I turn up, left, right, down, move my mouse like crazy, and I just see wall. So let's just go outside. We are a ghost, we can walk through walls. And it's a sphere. Oh, I did something stupid. The mouse control isn't working that well. So you see, it's just a plain old sphere. Let's look a bit up and down. Something weird is going on with that sphere. It seems to be a bit larger on one end than on the other. That's unusual. We'll get to that trick later. But you see, I moved out and it's just a sphere. So let's this time stay inside. We always see wall, it's green, so it's in the center of our 3D slice of the world. Let's look upwards. What is happening? As you see, the color transition at exactly this point means that there is less and less in the center and more in the bottom. So actually the top is now free and there is nothing at the top which is blocking our view. And now even the bottom is cleared. And at some point it starts reversing again. So at this point we are looking directly through the hole in the top of the cylinder in the 4D world. Let's move upwards. And look down again. And there it is. The hole in the sphere we just walked out. So we were in a hollow sphere, we turned a bit around and we just found a hole. And it looks suspiciously like a cylinder. But it's a sphere. It is a sphere. And look, as we turn here, we move it to different locations on our view spot. So a rotation in the fourth dimension does not look the same as a rotation in the third dimension. At least not in this rotational engine. So maybe it's broken. And there it is, our great cylinder, which looks like a sphere again. We just moved around it. Maybe the idea that we have a first-person camera isn't the best. So maybe we just should make the camera fixed and the objects turnable, but I personally prefer first-person games. There's definitely some problems to the mouse control, especially these vectors here, which have forward, right, up as in a usual Raytracer, and WAP, which is another vector into the fourth dimension. I just had the freedom to be the first one to name it. Yeah, I think that's it. You have to know about all of this. I will take this whole project and try to squeeze it into a GitHub, and the link can be found in the description. So for the next video I'm probably doing a bit of gaming, because I have currently no time to work further in that. I did add some comments for you, and tell me how you like it.